without further ado, we'll talk about IoT. So you guys, what do you think IoT is? Does anybody have a clue, an idea? Sure.
Internet of Things or Internet of Everything.
Internet of Things.
Device connected.
All right. So what does that mean?
Well, explain.
Sure.
Talking to your fridge, talking to your
Yeah. So what does that mean?
Control the things by
Controlling the devices, like through internet.
Make device smart.
Okay.
control things through internet.
So my smartphone is part of the Internet of Things.
Yeah, sure.
My PC is part of the Internet of Things.
Yeah,
Fridge.
How? What's the difference?
TV.
TV, maybe. Part of the
Everything
Internet.
identified by an IP address.
Sure, but that you can. A computer can be defined by IP address. TV can be defined by a server. Anything that has internet connectivity. Sure.
I will stand up for to explain.
All right.
Okay. Assalamu alaikum
أهلا وسهلا.
Internet of Things هو الفيوتشر. Can I speak in Arabic or?
Yeah, sure.
First time.
Go ahead.
الفكرة إنه كيف توصل العلم الآن بيتطور بسرعة. الأفكار الجديدة إن إحنا نوصل كل شيء عبر الإنترنت ويصير نتحكم بكل شيء. الإنترنت اوف ثينكس هو يركز كيف إن إحنا نخلي الجهاز القديم اللي ما يفهم شيء ولا نقدر نوصله بالإنترنت إنه يجيب لنا داتا ونربطه بشيء يكون نقدر نتحكم فيه collecting data. فالمعنى الأساسي للإنترنت اوف ثينكس هو كيف توصل device to device بهذا الشكل.
Over the internet. I have a very simple definition of the Internet of Things. So the Internet of Things is any device that can be connected through the internet to, this is important, to solve a specific problem. What does that mean? I want to control traffic. I want to detect motion. I have one specific problem that I need to solve. Any devices that come, it can be a PC, it can be a camera, it can be my smartphone, any device that comes into the picture to solve this problem is part of an Internet of Things solution. It's expected by 2020 that we would have 20 billion devices connected over the internet. And these are not counting smartphones, not counting PCs. So these can be traffic sensors, motion sensors, any type of sensors, or cameras or whatever that are connected over the internet. I like the sketch from Dilbert, which it's a bit long. It explains how the boss is tracking his employees' movement through a wristband. So he tracks all his employees through this wristband that sends this data over the internet to his tablet. And he knows where he's spending time, where he's goofing off, and he's interrogating him. So is this the future of the Internet of Things? Maybe.
Invading privacy.
Maybe. Flynas, for example, Fly Dubai. Last month they tendered a project, an IoT project. They wanted to track all their people across their entire facilities and know exactly where they went, how much time they spent, with video tracking and picture tracking of everything. So they want a video record and also photo record of everything. So it may be the future. So you never know. To go into more detail, Internet of Things is not just something, it's an ecosystem, meaning that we have software involved, we have hardware involved, we have the internet backbone, we have my smartphone is involved, we have a lot of things connected together to form this, what we call an ecosystem. So, on the first part, we call the first part of the Internet of Things is the data collection part, where we collect all the data. This can be pictures, video, Facebook feeds, Twitter feeds. This can be sensors, for example, temperature sensor, weather stations, whatever. These can be, I said, devices, data from your smartphone. For example, how does Google know if it's crowded in Medina Road? It collects data from your smartphone. So this is an Internet of Things solution used by Google to detect the traffic in Jeddah or all over the world. Also sets. What I mean by sets is any type of unstructured data. or structured data. This can be, for example, population records in Jeddah for the past 20 years. This can be used, aggregated, combined with other types of data to gain some insight or some action that I need to solve or to solve accordingly. So once we have this, we collect all this data, we come to the acquisition part, which is the data aggregation, meaning that we combine all these data sources together. So I combine let's say I want to collect information on someone. I can collect his Facebook feeds, his Twitter feeds, his LinkedIn feeds. I can collect his traffic movements through Google, whatever. So all this data can come together into one pile, one source, or one aggregator. This can be RPC, this can be microprocessor, microcontroller, board, single board computer, whatever, to process. So this is the third part. We analyze the data. We can apply machine learning algorithms, artificial intelligence. We want to predict, for example, if we're talking about stock markets, we want to predict the price of stocks in the future. So all these algorithms can be applied on the third stage. At the end, the fourth stage is to get the insights. In the end, after I apply all these algorithms, I want a result. I want to understand what's the stock price for Jabal Amar going to be tomorrow? Is it going to be raining tomorrow? Should I, for example, in Medina and Tahliya road instruction, should I build a bridge? Should I build a tunnel? How's the traffic there? So all these actions, or all these insights, we can get them through from the processing stage, and we can compile reports or have a visualization dashboards. Also, of course, these are the insights part. The action parts go back to the devices themselves. So they can be motors. They can be, for example, if I'm out of milk in my house, the fridge can contact Amazon to send a cup, or my supermarket or whatever, to purchase 2 cartons of milk and bring them home and send them home. So these types of different types of actions. So and I'm going through the presentation. I'm going to give you a lot of examples. IoT is not about the technology really. It's about the business cases, about the examples, because there's hundreds of examples, and till date nobody was able to exactly capture all these cases. So we'll see a lot of things as we progress, go along. First example. So we'll talk about examples. First thing is from IBM. This is in Dubai, IBM Dubai. What they did is that they used their employees' smartphone to track all these insights, to know, let's say, where they are speeding, when they are speeding, if they are, for example, accelerating, if they are braking, they are entering into a wrong lane, or whatever. So they're collecting all this data just from the acceleration sensor data from the mobile phone, nothing else. They don't know anything about the employee. Through the patterns they collect, they can understand, for example, that on this road, everyone's moving slowly. On this road, for example, here, everyone's speeding. This means if I'm Dubai municipality, for example, I need to install some cameras here, some SAG, over here and over here, for example. So this is the data that I can collect. This is a project, talking about our own projects. This is a project we did for Oklahoma Department of Transportation. You will see lots of these tubes here in Jeddah sometimes, these are actually counters, switches. So they count the cars that pass over them. If you have one, it's just a counter. So it just counts how many cars passing through. If it's 2, it calculates the speed of the car. You have, you know the distance, you know the time that the first car and the first car hit the first tube and the second tube, so you can calculate the speed. So this is kind of a platform. This is an IoT platform that we built for them. So and you have these tubes. These tubes are connected to a microcontroller, let's say, device. This is connected to a 3G, same 3G SIM card, that uploads the data to a server. From the server, we get all these readings. Let's say these are the counters placed all over the city of Oklahoma, I think. This, and you can get all data. You can get, for example, how many cars during this date have passed over this highway. What's the average speed of vehicles? Even there are weight sensors that you can add here to know what type of vehicle. Is it a truck? Is it a car? Is it a motorcycle? Whatever. So going forward from this, we were able to track actually 15,000 traffic counters across the state, meaning about 1 million data points every day. Of course, this is the traffic count information system is used for planning, meaning that I understand if I have lots of traffic in one road, then I need to plan to either widen the road, maybe build the highway close by, and so on. So this is used for planning, road planning. A second example, second project which we built was in Canada. Canada is famous for gas fields, so they have lots of gas fields in very remote areas. When the gas field is about half empty, the water, because gas flows on top of the water, when I'm pumping pumping the gas, after a while, I start pumping water with it. So there's a technology that they use called the plunger. The plunger, it's like kind of a stopper, yeah. So it's kind of a device when the pressure, the pressure is low, meaning that I'm pumping water. This kind of plunger, it goes down through the tube, and blocks the tube, meaning that I increase the pressure on the tube. When I increase the pressure, then the gas and water are separated. So after the pressure increases, this plunger, it shoots back up to the top. And so with this motion, it goes up and down, I can pump more gas. The problem happens, what do you think, when does the problem happen here? Gas is finished for it, but gas is finished, خلاص, this is, we'll close the station before that.
If it gets stuck.
If it gets stuck, then the pressure increases, and then there's an explosion. So I have to detect in real time, every 5 seconds, the pressure. The pressure at the plunger, the pressure in several areas, 3 areas. Here, the pressure over here, and the pressure over here. So there are multiple sensors as we go. We understand the pressure in different areas. And we need to understand that every 5 seconds, so that we can get an alarm. So this is kind of the system that we built. The system it's based on Azure platform. So Microsoft Azure platform. This is we were using ASP.NET. We deployed the sensors on these plunger sites. So you would see these sites in very remote mountainous areas all over Canada. So thousands of kilometers between site and site, and you get all the data in one place. So at the site, we had a 3G connection. This 3G connection sends the messages over the internet to our Azure platform. It stores all the data, which we call in a database, MSQL database. And then we have a separate, this is the IoT platform. It just queries the database and displays all the data. Here, of course, we have, for example, a graph of the pressure across different sensors. So this is sensor 1, sensor 2, sensor 3, and the different colors are different sites. So once an alarm goes off, an SMS is sent and to an SMS, and of course there's a visual alarm here. Some I think red screen pops up, some red window pops up, and you get an SMS that there's a problem. You have to go check the site. Of course, the monitoring site is a redundant system. Of course, on the site itself, there's a SCADA system. The beauty of IoT, if you can control anything, if you can send data to anything over the internet. So you can have, you're not bound by by any geographic area. You can send and receive information from anywhere in the world to anywhere in the world. Some do's for the business use cases. I'm going to go quickly through these. Yeah. So for me, most importantly, this is from Microsoft. The most important things for me is to start small. Don't think big of huge implementations. Experiment with small minimum viable products, which is very small implementations, very small project. Test it out. If it works, go bigger and bigger and bigger. Don't start big and think we want to spend million riyals on one solution. I recommend it for management. Let's start something very small, 10,000 riyal, 5,000 riyal, maybe. Very small implementation. Test it out. If it works, we can go bigger and bigger. So security is central. So understand that these devices, they have low power microcontrollers, so sometimes they can be hacked. So you have, all the connections need to be secure. So you have to understand the security. And if these devices are hacked, what is the consequence to you and your company? So you need to understand that. And of course, finally, is that IoT is based on ecosystem. There are hundreds of vendors. Some sell you devices, some sell you hardware, some sell you software. So you need to understand all the ecosystem to understand how to implement an IoT project. Don't confuse data with insights. You're just collecting hundreds or millions of data points. It doesn't mean that you understand anything about the data. You need to go to analyze this data to get some meaningful thing to me. For example, am I losing money or making money? How can this help me? How can this help the corporation? So building a solution for all your needs. Of course, solve one specific problem. Don't solve all your problems with one solution. Over pivot on technology, meaning that implement different systems and different solutions. Try to minimize your exposure to technology, meaning that try a solution from 2 or 3 different vendors. Don't say, well, I want a Wi-Fi with Bluetooth and Zigbee all connected to one device, and I want to have different technologies in one system. Try to make it as simple as possible. Focus on future requirements. Focus on how it's going to scale in the future. Develop your own infrastructure. Of course, don't develop your own infrastructure, IoT infrastructure. Yeah, don't develop. If you're not a vendor, if you're not a supplier, don't do it for yourself. Have a programmer and say, let's build one IoT platform. Get it from somewhere else, because there are hundreds of solutions and many are actually free. So don't do it yourself. If you're a business, of course. See middleware as IoT, think connectivity is not. Of course, you have to think of connectivity. Sometimes the tower is down. If you have a 3G solution, the tower is down, there's no connection. How is your system going to react? Am I going to lose? If this is an ATM machine. This is an ATM machine. If the connection is down, what's going to happen? Is it going to spit out all the money in the machine? So it's a problem for me. Underestimate, of course, the better the sensors, the better the solution. And forget that IoT is devices and software. Of course, IoT is it's an ecosystem. It's hardware, it's software, it's cloud services, it has web development components, it has firmware development. It's a whole stack of solutions on top of each other. Word on security, of course, don't forget that all your links should be secured, all your links should be over SSL, so everything should be encrypted. You shouldn't send data in the end and end up at your own house, not letting you inside your house. So if you watch the movie IT, you'll see that it's the same, it has the same problem. Some people are hacking the devices, and they're making one's life a hell. So you need to understand that. Finally, the best security is to turn all your devices off. So that's the best security. Finally, the word on privacy. Of course, this is kind of a small sketch, which is actually true. Some companies actually track you to the level that they know, for example, if your smoke alarm goes off, they can send you some services, like fire extinguishers. They can tell you, okay, you can stay and have temporary, they can give you offers on Airbnb or whatever. So this is actually real. This is not fake. Some are the level of privacy. So you need to understand privacy. We all know the story that happened with Cambridge Analytica and Facebook. 50 million accounts details of accounts were released, and this changed the election in the U.S., or it might have changed the election in the U.S. So it's a big thing. It's not something that we don't care about, or it's something secondary. It's
Facebook lost a couple of billions.
a couple of billions. Billions, not millions.
Billions.
So thank you very much. We'll have a 10-minute break. Set up your laptops so we can go inside, delve deep into our workshop. Right. Thank you. Do you have any questions? If you have any questions, feel free to ask me during the break. So today what we're going to do is to do some examples using Node-RED on a Raspberry Pi. So what are all these terms mean? A Raspberry Pi is a single board computer. So it's a board that has a microprocessor on it, running Linux on this device. So it's a Linux operating system. In it you can have any program, run any program that you want. It has many peripherals. So these are inputs and outputs where you can send data and receive data. You have an Ethernet. These are 4 USB sockets. Here you have one Ethernet, HDMI to connect to TV or screen, audio output, and then you have this connectors for display, and this one's to install a camera, to install a camera device. So this is one of the most popular, let's say, devices for hobbyists. It costs depending on the version, between $30 to $100 per piece. So 100 riyals to 500, 600 riyals device. It's one of the cheapest in the market and the most powerful.
Is it possible to use Arduino just by itself?
Yeah, of course. Arduino, the levels, now we have different levels. The single board computer is, let's say, on the top of the hierarchy or the stack of embedded devices. You can go, the higher up you go, the less control, the less visibility of the pins or the output inputs of your device that you have. You can go lower to an Arduino. Arduino is a very small board that has a microcontroller, 8-bit microcontroller from Atman. It's called an AVR microcontroller. This you can have, you can control pin by pin. So you have very low visibility or very good visibility of what you're doing, the inputs and the outputs and the data that you're transferring. As you go up, you can go from 8-bit microcontrollers, very cheap, less than, I think, 1 riyal per piece. Go up to 16-bit microcontrollers, to 32-bit microcontrollers. All of these, they run...
Depends on the work that...
Depends on the workload that you have. They run native, so native code, meaning that you run C programs, meaning C, of course, under that, assembly, and then machine code. So very low level, you need high experience, very good experience in programming embedded systems, very good knowledge of programming low-level languages like C. And as we go up, of course, there are people, because of the success of the web, people are trying now to bring in web development into embedded systems. So instead of using C and assembly and whatever in these languages, we use JavaScript. So we use JavaScript to program these devices. So to program these devices, of course, when you're using JavaScript, which is a higher level language, the problem is that it utilizes more memory. So when you have these are very cheap systems, they have very low amounts of memory on them. So when you're using a higher level program, it actually takes more space of the memory. And so on, you can run less code on it. So you need to, you need to understand the benefits and both the benefits and let's say the things, disadvantages of using these or the drawbacks. Now, as we said, we're going up. We said from the 8-bit microcontroller to 16-bit to 32 bits. Then there are coprocessors, a system on chip, where you have a microcontroller that runs the low-level code to control all the pins. With it, there is a microprocessor that runs Linux, and on it you can run your high-level services, such as you can run your web. You can run Node.js on it, and from it you can do a high-level coding using JavaScript. Node-RED goes on a level. It's just a user interface. It's a visual programming tool. This sits on top of Node.js. So we're using, let's say, we have the bottom level is assembly, or ones and zeros. Above that you have machine code, assembly. Then you have C. Above C you have JavaScript. Above JavaScript, then, it's not above, but server-side scripting, we use Node.js. Now, a visual tool to program in Node.js, in JavaScript, is called Node-RED. It's just simple blocks that you push onto this display or user interface, and just to connect the blocks together. And then you push deploy. Once you push deploy, you have the program downloaded onto the device itself, and you can control the device, read data, send data, control pins, control motors, all through this visual tool. Let's go to this web link. If you go through it, you will see this page. This actually is the web page for Raspberry Pi installed in New York. So we have a Raspberry Pi run with an LCD screen, and we have a camera that's taking still shots of the actual board. So we can actually, from here in Jeddah, control the device that is sitting in New York. Let's go check the camera. So you have two links down here. You have my IoT camera, list of sensors, camera sensor. So this is a kind of a photograph from the board itself. This is a Raspberry Pi here under it, and this is the Raspberry Pi, and then you have an LCD screen connected to a couple of sensors. Of course, let's if you go to the same link and then go to the Raspberry Pi itself, we can actually see sensors. So we can see the temperature in the office, 21 degrees. Let's go back to the actuators from it. Let's see this. So we saw the LCD display screen. To make sure that this is actually real, we're not just coaxing you into believing that this device is actually somewhere else and we can't control it. You can write anything over here. So let's say I want to update it. And then refresh my camera view. Somebody else sent hello world.
Yeah, that's me.
Yeah, that's you? Yeah. Hi from Facebook developers. So from here over the net, we can send these values to this device. And this is from Everything Office. Everything is an IoT company based in New York. And the founders of the company, they authored a book called Web of Things. It's a very interesting book that delves deeply into the topic of the Internet of Things and how to, with real examples on Raspberry Pi. So okay, that's good. We saw that this is a board that we can control and write some data and push it out to an LCD screen. Now, how can we do it ourselves? Using a visual tool such as Node.js. So I prepared a couple of examples that we can go through just to learn what is Node.js. Node.js, sorry, Node.js. So open the